Okay, we are still doing the day 2. This is the second page, example 3. We also talk about this one in the day 1 note at the end. When we have lots of training sets like those things, then if we want to draw a best fit line, find the best fit line, how can we calculate the error? So we can think about that as a real value. Then for the same x coordinate, passing at the best fit line as expected value. So we can think about the difference between real y value and expected y value for the same x coordinate will be the error. Then if we find all the errors, then add them. That is total error. When we find the difference, we can use absolute, but that is really hard to calculate when we want to use a derivative to find the minimum error. So we are going to use a square instead of absolute. So actually you can say real y value minus expected y value or expected y value minus a real y value. The order really does not matter because we do square. Then we are going to calculate all the errors, sum of the all the errors. In this case, Pix means ith point x coordinate. P sub iy means ith point y coordinate. They are given because this is a real values, real training set. So they are not variables. Unknown variables will be a and b. This a x plus b means the line equation y equals ax plus b. That is the y value, right? Expected y value. So variables are a and b. So we are supposed to solve for a and b. We can think about this the same question in a little bit different way. So we are going to change the error formula a little bit. Instead of real y value minus ax plus b, we want to have ax plus b minus the real y value because for a and b, we do not want to keep negative. So we want to make a and b as positive, keep the positive. So this is a better way. So we are going to write it this way. Then one more thing. The reason we do square is because we wanted to do derivative. So when we do derivative of this equation, expression, whatever, because it has a square, finally we're gonna have 2 times something, then something. So we have extra 2. So to get rid of that extra 2, we are gonna multiply 1/2 to the formula. So our new error formula is 1/2 sigma ax plus b minus y square. Then by using this one, we are going to find a and b. But it's really complicated because it has a sigma, so we are going to set something, name it. P sub x, we are going to say sum of all the x coordinates. P sub y will be sum of all the y coordinates. P sub xy will be sum of all the xy product. Then P sub 2 will be sum of x squared. So this is just a setting to write simply. Then we are going to get the partial. So partial E respect to B, we want to finally get no error, so 0 vector. So we are going to set this partial as 0. Also, partial E respect to A will set as 0 too. Then if I write first partial, so derivative respect to b, so you are going to do derivative over this one, 1/2 something square, so it's gonna be like 1/2 times 2 something. That's a chain rule. Then inside of this something, b's coefficient is only 1, so derivative of b is 1. So finally, when you simplify that, you're gonna have a p sub x. because sigma px is p. Sigma x coordinate will be p sub x. We already set up at the beginning. Then constant in the sigma is just how many n times b minus sigma p sub iy will be p sub y as our setting. Now, if we want to get the partial respect to a, you are going to see here. So 1/2 times 2 times something times inside. So you are going to derivative inside respect to a. So there's only first term is a times something. So p sub ix will be multiplied by using the chain rule of derivative. Then if we simplify, a times sigma p sub ix is, there's another p sub ix. So a times p sub ix, p sub ix. So if you simplify that, you can say a times p sub 2. Depends on our definition with setup. Then plus b times p sub ix. Sigma will be p sub ix will be b times p sub x, and minus p sub ix times p sub iy sigma, so p sub xy. Let's see this one. We said we are gonna set as 0 for this partials. That means we can add p sub y both sides. For the first one, we can add p sub xy to the both sides. So we're gonna see same variable a b. So they become the coefficient p sub x and becomes the coefficient. We can write in the matrix. Then p sub 2 and p sub x in the matrix. So this is a coefficient matrix. Then variable A matrix is A and B. Then resultant matrix is p sub y from the first one, p sub xy from the second one. Then if you use Cramer's rule, so find the determinant. Then instead of A, you're going to use p sub y and p sub xy. P sub y, p sub xy, then n and p sub x. Then another one for b, instead of b, you're going to use a resultant. So p sub x, p sub 2, then p sub y, p sub xy. Then if you simplify by using the Cramer's rule, you're going to get a as this one and b as this one.